right. Questions 9 to 13. Write your expression as a function m of t, where m of t is the total amount of money in Madison's account after t years. So we would write this as m of t equals the expression that we wrote down for A of 8. 10,000 times 1.05 to the t power. That is rewriting our expression as a function. Moving over to question number 10. Use the data from the table in item 2 to graph your function. Okay. Now, obviously, these are going to have to be some type of approximation. There's no way we're going to make these exact. So we'll do our best. We know that in year 0, there was $10,000 in the account. Okay. Then we had 10,500. Now, keep in mind, this is 15,000. So that makes this 12,500 right here. So keep that in mind as we go to approximate these along the way. Notice in year 4, it's 12,100. Well, remember I said this is 12,500, so it's going to be right under that line. And here in year 5, it crosses that line. Then it goes to, it's right above 15,000 in year 9. So let's kind of get that there. And so it's going to kind of go like so. It's not a straight line. It's more of a curved line, but it's not curving at a very drastic rate. Okay? Describe the function as linear or nonlinear, and I just kind of talked about this. This is definitely nonlinear. There is not a constant rate of change. Identify the reasonable domain and range and explain your reasoning. Now, domain, remember, are my x values or my t values in this case. Now, t is referring to the number of years that this money has been in the account. Can I have a negative number of years? No. So with my domain, t must be greater than or equal to 0 because the amount of time cannot be negative. Let's talk about our range. Our range keeps getting, that's that M of T, the money in the account. The money in the account is obviously going up. And I know that the money in the account can never be below what amount? The initial amount, which was 10,000. So M of T must be greater than or equal to 10,000 because that was the initial deposit in the account. Madison's future plans include purchasing a home, She estimates that she will need at least $20,000 for a down payment. Determine the year in which Madison will have enough funds in her account for the down payment. Well, I'm going to use my function. I know that she has $16,000 in her account in year 10. So, how much would she have in her account in year 11? 17,000, right? How much is she going to have in year 12? Almost 18,000. So, we're not at the $20,000 mark yet, right? Well, let's go up a few more. Let's go to 18. I got over 20,000 now, right? So now we need to kind of back up, right? Because I went too high. So let's go to 16. 21. So I'm still too high. Let's see if I can go down one more. So the earliest time, if I go down to 14, not quite there. So the earliest time that she'll actually hit the $20,000 mark is in the 15th year. And I used the expression and basically did the guess and check method just to see what year I would hit the 20,000. Go ahead and take a moment to write these down. Make sure you have all your answers from questions 9 through 13, and then we'll move on to the next set of questions.